Hey guys, today we're going to deal with integral exponents. That's your section 112. Sounds complicated, that's not really. First, I need you to get out of this video and go and watch the 7th grade video 1.9 because that's going to give you all the basic rules on powers and exponents. So then come back and watch the rest of this because we're actually going to go a step further here. Make sure you take notes on that other video too, because you need to have all of this in your notes. Okay, now that we're back, try these on your own very quick and see what you got out of the other video, and then we're going to check this, and then we're going to keep on going. So here I have same basis. I have -2 as a base for each one of these exponents, which means if I'm multiplying the bases, I can simply add the exponents. So my base is going to stay the same. Don't forget the parentheses around it. And I'm going to add my exponents, which 3 plus 2 is simply 5, and that's it. You don't have to solve it all the way. That's all I want for the answer. Let's try this one now. Again, bases are the same. They're both 6. If I'm dividing same bases, I can just subtract the exponents. So 5 minus 2 is going to be 3, so this is just 6 to the third. So far, so good. All right, now let's look at zeros and negative exponents. So for example, let's do this one. So this fraction bar just basically means divide. So you're dividing -5 to the second by -5 to the second. Well, you're going to end up with -5, and 2 minus 2 will give you 0. Well, as you probably saw in the other video, anything to the 0 power is simply 1. So that's it. That's your answer. Now, how are we going to deal if my exponent comes out negative? So here I have 4 as my base, and 2 here and 4 here as my exponents. Again, this means divide. So I need to subtract. So I'm going to keep 4 as my base, but then I'm going to have 2 minus 4. So different signs, you're going to subtract and keep the sign of the bigger. So you're going to end up with -2 for your exponent. Well, I don't like negative exponents. We are not going to keep them this way. What it means is you're actually going to flip your fraction around. This doesn't look like a fraction anymore. Technically, if you remember, it's over 1. So my 4 to the -2 is going to go to the bottom of my fraction. My exponent is going to turn positive because when I send it from the top to the bottom, or if it was on the bottom, I would send it to the top, it turns positive. And then on the top, I didn't have anything else there, so that's just going to be 1. Okay? So when I send my exponent to the bottom, it becomes positive. If it was negative and it was on the bottom, I would send it to the top, it would become positive. Okay, so just send it from upstairs to downstairs or downstairs to upstairs. That's all. Next, what if you have exponents outside of parentheses? This exponent -3 technically actually goes to both the top and the bottom if it's outside of the parentheses. So this is the same thing as 5 to the -3rd over 6 to the -3rd. Okay, so remember, if my exponent is negative, I have to send it, if it's upstairs, I send it down. If it's downstairs, I send it up. So I'm basically going to flip this fraction around. My 5 to the -3rd will go down, and my 6 to the -3rd will go up. So I'm going to end up with 6 to the 3rd on top because my exponent turned positive by bringing it up. And my 5 to the 3rd is going to go on the bottom. And since I brought it down, my 3 turned positive. And this is actually the same thing as 6 over 5 to the +3rd power. So instead of going through all of this is just basically to show you how it works. What you can do is, if you have something that looks like this, let me rewrite it so it looks a little cleaner. If you have something like this, you have a fraction in the parentheses to negative power, you can just go ahead and flip your fraction around, still keep it in the parentheses. So flip it around and turn your exponent positive. So let it sink in for a moment, and then I want you to try this. So let's go a little crazy here. So I need to pick out my same bases. I have 5 and 5 are the same, 6 and 6 are the same, 7 and 7 are the same. So I'm going to deal with this. This is division here. This big bar is division. So I can divide 5 to the second by 5 to the third. Well, that's going to give me 2 minus 3 is a negative 1. So I'm going to end up with 5 to the negative first times then 6 to the fifth and 6 to the fifth. I'm dividing. I'm going to subtract 5 minus 5. That will give me 0. So it's going to be 6 to the 0 times 7 to the fourth divided by 7 to the second. I'm going to subtract this, and I'm going to end up with 7 to the second. Now, I know that 5 to the negative power, I don't like negative powers, so I'm going to send it downstairs. So now it's going to look like this, 6 to the 0 times 7 to the second over 5 to the first. And then 6 to the 0, I know is 1, so 1 times anything will be that same thing again, so 7 to the second times 1 is still just 7 to the second, so that can just go away. And 5 to the first, anything to the first power is itself. So I'm just going to write this as regular 5 without the exponent because it's the invisible one there, it's just understood that it's there. So, and one last thing I want to show you. Give me 1 second, and I'm going to try one more example. Okay, so we're going to try this problem together. I didn't type it up because it's a pain to do this on the computer, but please do this with me. 3 over 4 to the third power times 3 over 4 to the negative 9 power all over 3 over 4 to the negative 4th power. So I'm not going to flip these around yet because I want the same basis. 3 over 4 is the base in this case, and you see 3 over 4 everywhere. So in order to be able to deal with these exponents, I want to keep my bases the same. So first thing I'm going to do is I'm going to go across the top. This is multiplied, so I'm going to add these. So it's going to be 3 over 4 will stay the same, and then 3 plus negative 9. Let me show you here. 3 plus negative 9. These are going to make a minus, so it's the same as 3 minus 9, which will give me negative 6. So this is to the negative 6th power now. On the bottom, we're going to keep it the same for a moment. Now, this is division, which means we're going to subtract. Be very careful when you're subtracting negative exponents. Don't forget they're still negative. So my answer is going to be 3 over 4 still, but then it's negative 6 minus a negative 4, like that, because I'm minusing them, and it's negative. They're both negative. So these two are actually going to make a positive. Negative 6 plus 4. You know how to do that. And then negative 6 plus 4, different sign, subtract, give the sign of the bigger, will give me negative 2. So that's the negative 2nd power. Now, since I have this negative here, what can I do to this to get rid of my negative? Well, I'll just simply flip it around. So I'm going to have 4 over 3 to the second. And that's it. You're done. So that will be it. And we'll unconfuse you tomorrow if you're confused.